Right, the last thing I want us to look at are the graphs of sec, cosec and cot. So here I've drawn my graph of y equals sine x. I don't know why, whenever I use squared paper, when it films, the resolution goes all funny, so I'm going to have to stick to plain paper. If you've got squared, please make sure that you're using it for your graphs. So I've got sine here. The reciprocal of sine is cosec. And I know that cosec is 1 over sine x. So let's start looking at some key points. If I look at 90 degrees, sine of 90 degrees is 1. And 1 over 1 is 1. So cosec of 90 degrees is also going to be 1. If I look here, where sine x is a half, 1 over a half is 2. So cosec of this same value is going to be approximately 2. And if I look here, or exactly 2. And if I look here, sine 0 is 0, cosec of 0 would be 1 divided by 0, but 0 is that crazy unknown value where when you divide by it, it goes up to infinity. So my graph is going to shoot up here up to infinity, and this is going to be an asymptote. So I can see that my graph is going to come down in a curve like that. Because of the symmetry of sine, this is going to ping back up in exactly the same way. And I'm going to have another asymptote here at 180 degrees. So this is going to be an asymptote. Okay, exactly the same as how the tan graph shoots up to infinity. So this one is also going to shoot up to infinity because that's what happens when you divide by 0. The same thing's going to happen here, except here I'm coming from the negative side. So if you divide by 0 from the negative side, you're going to come in at this point. Here, if we imagine this to be a half, if I take the reciprocal of that, I'm going to get, well, minus a half, sorry. If I take the reciprocal of that, I'm going to get negative 2, which would be about here. Here the value is negative 1. 1 divided by negative 1 is negative 1. So it's going to come in this way. I've done that really badly, sorry. And shoot up like that. With another asymptote here. And again, this is a repetition of this. So it's going to come in here, cross up 1. This is a repetition of this. So it's going to come in here. So from this graph, you can see that it's periodic in exactly the same way as the sine graph is. Its period is 360 degrees, or 2 pi. You can see it's got asymptotes. At x equals 0, x equals 180, or pi. At x equals 360, or 2 pi. And it will repeat like that. You can see that the graph of cosec does not have any values between -1 and 1. It doesn't exist between -1 and 1. So no values between -1 and 1. I would like you to try and do exactly the same now for y equals sec x and for y equals cot x. So draw your cos graph and draw your tan graph, and then think about what happens when you take the reciprocal of each of those values to try and find your shape of the graph of y equals sec x and y equals cot x. And then finally, for your final bonus, I would like to think about this. So you know the identity sine squared theta plus cos squared theta equals 1. That is a given thing, you know it, you love it. I would like you to see if you can use this identity to derive any new identities for sec, or specifically actually it'd be sec squared really, for sec squared and for cosec squared. Okay, so your challenge, and it is a challenge, this isn't compulsory, is can you start from here and can you use this statement here to derive any new identities for sec squared and cosec squared? This is not compulsory. The rest of the work is, this isn't. If you can, show me a picture of, take a picture of how you've done it, email it to me, and actually let's be generous. Let's say the first three of you to show me how you derive these new identities from this one here. I will post you a chocolate bar.